Welcome to Multivariable Calculus Series, and this is the second episode of that. This one's a lot simpler than the previous problem, and the link's in the description. So anyways, we are going to find the partial derivative of the function with respect to x and y of e raised to x plus y plus 1. Oh man, exponential functions, I love you, because you're the same derivatives and the same integrals. But this one is a different game, or is it? Let's find out. Alright, redefine the function first, which is going to be the same as e times e raised to x times e raised to y. And now, finding the partial derivative with respect to x, so that's going to be the d of f with respect to d of x of e times e raised to the x times e raised to the y. So in this case, I'm differentiating with respect to x, and whatever does not have an x is my constant term. So the constant term just gets out of the derivative. In this case, it is e times e raised to the y times the derivative. Well, in this case, I might be writing partial derivative, but it really doesn't matter which derivative you use, because you only have a function of x and there is no need for a partial one. So I'm just going to stick to the single variable differentiation notation, which is just going to be d of dx of ex. As you know, that is just e of x. For those of you who don't, I will be uploading a proof of why it is so later. Anyway, so that is just going to give me e times e raised to the y times e raised to the x, which is the same old function, because I can just add up the powers. E is just e raised to the 1, if you haven't noticed already. E raised to x plus y plus 1. Hey, it's the same old function. We're done, but not done, because we got to find the second part as well. Now that is the derivative of the function with respect to y, and the function is the same function, that's e times e raised to the x times e raised to the y. So in this case, whatever, I'm differentiating with respect to y, and whatever does not have the y, aka this term, is just a constant, gets out of the derivative. So that is e times e raised to the x times the derivative of the function, that is just e raised to the y with respect to y. And guess what? That is e raised to the y again, because of course the exponential function is a unique function. It's got the same derivative, the same integral, everything. So that is just going to give me e times e raised to the x times e raised to the y. And adding the powers up again, I get e raised to the x plus y plus 1. There we are. Again, it's the same old function. But of course, you got to keep in mind always the rules of partial derivatives. Make sure you know the variable which you're differentiating with respect to. And whatever does not contain that variable is a constant, no matter. It can be a log of x or natural log of y function. Doesn't matter. If it does not have the variable you're looking at or differentiating with respect to, just consider it a constant, shove it out the derivative. Thank you.